Okay. We ended in chapter 8 last time, I believe. Logical structures and selection of structures. Logicals. Now we're into repetition structures, chapter 9. We still have, so after chapter 9, we're going to skip some things. We'll skip chapter 10, matrix operations and functions. The reason we skip that is because what this is all about is what we call matrix algebra, which is mathematics. It's a little beyond the scope of the prerequisites for this class. So it's very useful stuff, there's no question about it, but since we haven't required you to understand those kinds of mathematics, we will not go into that. Chapter 11, we can either choose to skip or not, depending on, I mean, it's also a very useful chapter, but I think we might skip it. It covers the idea that you can make different kinds of arrays, that not just arrays of numbers, but arrays of words, arrays of other kinds of data, arrays of, you can make arrays of arrays. You can make multiple dimensional, 5-dimensional arrays and so on like this, arrays of cells, all kinds of things, which again can be very useful, but I think we're going to skip it so that we can try to get on to some more of the programming that is more generally applicable. Particularly, we want to look at graphical user interfaces. We'll also skip chapter 12 because, again, it's beyond the scope of this particular class. It's all about solving mathematical equations, algebraic equations, things like this. Very useful once again, but it's not really supposed to be part of this class, so we're going to skip that one. 12.4, I mean, it goes into calculus and everything else in that one in chapter 12. So that's beyond the scope. Again, we're just going to move on. And then chapter 13, we are also going to skip. It's called numerical applications, and this has to do with solving mathematics using numerical methods instead of symbolic methods. In symbolic methods, you solve using algebraic rules and laws. In numerical methods, you just keep plugging numbers in until it works, and that's what MATLAB is very good at doing, that because it can plug in a gazillion numbers in a very short time and check things. But again, beyond what we're supposed to be doing. So we're going to skip all the way from chapter 9, which we're doing today, to chapter 14, I believe it is. Is it? Let's see if we're there. Yes, chapter 14. We're going to skip all the way to chapter 14 after chapter 9, skipping a total of 5 chapters. And we're going to go into advanced graphics and learn a little bit more about how we can manipulate imagery. We can make imagery using some advanced graphics, doing some animations, and then we will move on to graphical user interfaces in chapter 15. So after today, we are essentially going to have 2 more things to do: advanced graphics and graphical user interfaces. Chapter 15 we'll spend a fair amount of time with, so that we can really learn that. That will give us, let's see, what's our date today. Today is the 12th, chapter 9 today, and then 2 more chapters. That will give us 2 weeks essentially to do a final project. Not as much time as we wanted, so we'll make the final project a little simpler than before, but we should be able to get in a little bit of time the week before finals and the week after, the week before finals and the week of finals to finish up a final project. And we will meet that week of finals to, on whatever day, there's not a day scheduled for us to meet, so we'll probably just meet at a regular time or whatever. But we'll try to get together to discuss final projects and see how that goes. So, let's talk about repetition structures. Close everything up here. Last time when we talked about logic and structures that use logic, like the switch case structure, the if then if structure, or whatever they called it, Can't remember. It's different in every language, and I've used more than my fair share of languages programming, at least from my point of view. But anyway, the if statements and the switch statements, those are structures that allow the computer to make choices and decisions and do things that are more, you could think of as intelligent. It's getting a little bit closer to being intelligent rather than just plugging in numbers and spitting them out. Bear in mind that this is nowhere near real intelligence, but it's still a step in the right direction. Repetition structures are going to be even another step in that direction, where we are going to tell the computer to do something until we meet a certain criteria, until something happens that it's looking for to happen. And so it's going to continue to do so. It's like telling somebody to work on weeding the lawn until the timer goes off, or tell somebody to vacuum the carpets until they're clean. You know, you're doing something until you meet some kind of criteria. And that's a really good thing to teach a computer to do, because it gives the computer that one extra level of ability or intelligence, again, you could think of it as. So anyway, repetition structures. We're going to start off with what is called the for loop. We're on page 312, section 9.1. A for loop is a repetition structure that is designed to do something for a certain amount of repetitions. So we give it a task. We say, I want you to go out and walk around the lawn, and I want you to do it until you've walked around the lawn 10 times. That would be a for loop kind of repetition, where you give it 10 repetitions to do, and you tell it what to do during that repetition. Yes, sir? 312, section 9.1. So, in order to create a for loop, we first of all have to know how many times we want it to do it. Then we have to tell it what we want it to do. But then we also have to tell the computer which loop it's on every time. It has to know that somehow, because computers just don't know that automatically. We have to tell it. Computers don't do things on their own. We have to give it some kind of instruction in that regard. So let's make a very simple for loop. Let's do this one. So to start a for loop, we have the command for, and of course it highlights it in blue, and that means that MATLAB knows what that is. It knows that we're creating a for loop. Then we're going to give it what we call an index variable. And you can use anything for an index variable. You can use n, k, p, r, s. You can give it a name, Joe, Fred, Box, whatever. You know, whatever, but we usually use just a very simple variable. In this case, we're going to use k. And then this k needs to have some values. Okay? In some programs, you say for k equals 1 to 5, then it just knows it starts at 1 and it goes to 5. But in MATLAB, we're used to working with matrices and arrays, and so we give it an array value. So we say that for k equals, and we're going to create an array. And our particular array here is going to be 1, comma 3, comma 7. So here's our array for 3. Sorry, let's put this up on the screen. I forgot to do that. For k equals 1, 3, 7, we're going to do something. Now then we hit return, and notice that it doesn't bring up the prompt even in the command window, because it's now waiting for us to end this loop. Okay, so for k equals 1, 3, 7, we need to tell it something to do. We're going to tell it to do something very simple. I'm going to just tell it to print out k. Tell me what k is. So I'm just going to say k, and I'm going to end this. What this is going to do is it is going to start the loop, and it's going to say for k equals 1, 3, 7. So the first time I go through this loop, it's going to take the first number, k equals 1. And MATLAB now knows that k equals 1 the first time we go through this loop. Then it's going to go into the program. And the program says k, print k to the screen. So it's going to say, well, k equals 1 this time, and it's going to print k equals 1. And then it's going to go back through the loop, and it's going to look for the second value of k. And it's going to keep going back through the loop until it runs out of values of k, and it's going to keep printing k to the screen. So what's it going to do? K equals 1, k equals 3, k equals 7. Right? And it's done. Very simple. Okay? I want you to each write your own program for k, your own program for a for loop. But this time I want you to tell it to do something with k. K is now a variable every time it goes through the loop. and I want you to use different k's. I want you to make your own thing of k. I want you to do something clever. Maybe have it calculate the square of the first 10 numbers. You can't use that one because that one's the one I already used. But do something that's not in the book, something that you can look at the ones in the book to get some ideas. But do something on your own and make a for loop. In the meantime, I'm going to go eat something really quick because I didn't get a chance to eat it. You guys make a for loop. We'll come back and talk about your for loops. Have you guys come up with anything yet or need any more time? Raise your hand if you need a little more time to make your for loop. Okay. You're making a for loop. Yeah. A for loop is a loop that uses this command for, and then you give it some index, just like in the example here. And then you tell it, so you give it some programming thing to do, and it will go through the loop for every value of k and do that program. It will do whatever you tell it to do for each one of the numbers you tell it to do it for. I'll make another example for you. Here is 4. I'm going to do n. This time I'm going to make an array using this format, 1 to 10. So from n equals 1 to 10, return. Now so it's going to go through this loop 10 times. The first time it's going to have n equals 1. The second time it's going to have n equals 2. The third time it's going to have n equals 3. So I've told it how many times it's going to go through, and I've also told it what n is going to be every time it goes through. That's what I did with that line. N is going to be 1 the first time it goes through, 2 the second time it goes through, and 3 and so 4 and 5 and 6 and so on and so forth. Now I'm going to tell it to do a couple of calculations. I'm going to say m equals n times n plus 1. So it's taking the number, the first time, remember that n is going to be equal to 1. So in this line, it's going to assign a new variable to m, and m will equal n times n plus 1. So it's going to be, for the first time, it'll be 1 times 1 plus 1, so it'll be 2. M will equal 2, right? And then I want to print off to the screen. So notice that I suppressed this to print to the screen. This isn't going to show. But I want to print to the screen m plus n. And then I'm going to end this and we'll see what happens. So it gives me the answer for the first time it went through is 3. Is that true? M equals 1 times 1 plus 1. So that's 2. And then I add 1 to 2 and I get 3 for the first time. And then the second time I go through, n is equal to 2. Right? And so on and so forth. And I get this, this group of answers. I get a new answer every time it goes through the loop. So this is one way we can use a for loop, is to start off by giving it an array of numbers that it knows it has to use up before it ends the loop. and then I give it some things to do with those numbers, and then I end the loop. There are other ways to use a for loop, which we'll learn about here in a minute. This is just a very simple way. It doesn't have to be anything particularly amazing, just find something to do here. All right, we got a for loop put together. What'd you guys do? A equals 2 to 200 in steps of 2? Yeah. Mm-hmm. And then you did what? I divided it by 2. Divided it by 2? Each time? Cool. What about you, Matt?
I did something similar. Did 1 to 5.
1 to 5.
N equals 10 divided by n plus 8 raised to the 3rd.
Okay, so you did some arithmetic with it.
And then I took the m and subtracted the initial thing.
Good.
That
Good. It's just, I mean, and you get an answer every time it goes through the loop, right? Unless you suppress the answer. Let me show you something I just did. I did I calculated how much money I would make if I put $1 in my savings account the first day of the month, and then the next day of the month I put 2 times $2, and the next time I put in 2 times, no, I put in 2 times $1, so I put $2 the first day, and then $4 the next day, and then $6 the next day, and then $8 the next day. So essentially, whatever day I was on, I put $2 times that number of the day, right? See how much money I would save by the end of the month. And it turns out that I would save $930 by the end of the month. And the way that I did it is I started with n equals 1 to 30. I deposited 2 times that number n in. That's my deposit. My savings was equal to savings plus deposit every time. But the important thing about this loop is I had to start out with a variable called savings that had to be equal to 0, because I had said that savings was equal to savings, right? And so I had to start out with a variable that was equal to 0, so that when I reset that value to something else by adding it to what it was before plus a deposit, that it would keep adding to itself. This right here is what we call it's kind of a recursive statement, not really, but anyway, this statement, it refers to itself, right? Savings is equal to savings. You are calling savings itself plus something else and then reassigning it a new number. And that's something we do a lot in programming. And then at the end, after I went through this whole loop, I didn't print anything off. I suppressed everything, right? I suppressed both lines of my output, so it didn't print anything to the page. But after it was done running the loop, I asked what my savings was, and it went to 930 instead of 0. Right? So there's a lot of things you can do with for loops, and for loops are used constantly in programming. They're used so often. Very useful, very well used, very often used tool. Let's see, let's go on and do some others here. So here's another good one, page 314. Oftentimes when you're running loops, you need to start off by setting up your variables with initial values. So first of all, I'm going to start off with a set of scores. These are maybe test scores or something. We have a 76, we have a 45, oops, we have a 45, we have a 98, and we have a 97. Those are my 4 scores for test scores here. And I'm just going to go ahead and, oops, I'm just going to go ahead and define this as an array of numbers, and that's great. Then I'm going to start off with an initial count. I'm going to just call it count equals 0, right? Now, what I want to do with this, let's say that I want to count how many people got a score greater than 90%. Okay? So how do I do that using a for loop? Well, one way I can do this is set up my for loop but I want to go through this loop as many times as I have scores in my array. So what I'm going to do is I'm going to say for the length of scores. Remember that the length thing counts how many things there are in scores. So this is going to go through how many times?
97 or 98 times.
What is the length of the scores array? 4. So it's going to go through 4 times, right? And it's going to go through the loop 4 times, and it's going to do something each one of these times. Oops, didn't finish. I forget I have to give it a number of numbers, right? So it's going to go from 1 to the length, and I have to give it a value. What do they use? They use K? Yeah. No. Yeah, K. So for K equals, so remember that I have to give it an array of numbers to work through. So it's going to go from 1 to the length of scores. So it's going to go from 1 to 4, right, for this for loop. And then once I go through it, what I want to do is I want to give it a statement. I want to give it some kind of choice to make. So I'm going to say if, I'm going to put an if statement in here. If scores, and I want to look at the first one. So I'm going to look scores k. In the first time I go through this loop, it's going to be k equals 1. The last time I go through this loop, it's going to be k equals 4, and in between it's going to be 2 and 3, of course. But the first time I go through, I'm going to look at scores 1. I'm going to look at the first element in scores, which is going to be which score? Which value, which number up here is going to be scores 1? It's going to be the 76, right? The 76 is the first element in the scores array. So it's going to look at 76 the first time through the loop. Second time through the loop, it's going to look at 45. Third time, it's going to look at 98. Fourth time, it's going to go look at 97. So I'm going to say if scores at the k value, whatever value I'm at the point, is greater than 90, then I'm going to have it do something. I'm going to have it make the count, which starts at 0, right? I'm going to let the count equal count plus 1. That's going to add 1 to my count. I'm going to press that. I'm going to end my if statement, and I'm going to end my for loop. So it does the loop, and now it should have the count. So I'm going to ask, what is the count? And the count is 2. It counted 2 of those. Right? So it's another way to use the for loop. You can actually set it up with numbers that are not necessarily known until MATLAB gets the command. In this case, it didn't know how long length of scores was until it started going through the loop, and it had to figure out what the length of scores was. And then it knew it was going to go through 4 times from 1 to 4.
Why did you put it in twice?
Because the if statement needs to be ended. This if statement, anytime you have a blue come up, anytime blue comes up in your MATLAB, you have to end it eventually. So the if statement, once I was done with my if statement, I ended it, and then the for loop also needs an end. These are called nested structures. The if structure and the for loop structure. The if structure is inside of the for structure.
What does the two, what does the count equaling to,
What was I counting? This is the question I asked. If my scores is greater than 90, then I add 1 to my count. What am I counting?
oh, you only have 2 scores greater than
I'm counting the number of scores in that array that are more than 90, right? So that's what it did. This can get really confusing really fast once you start doing larger programs with these. So it's really important that we use some of the skills that we learned last week when we were doing pseudo programming. Remember when we kind of just sketched out what we wanted the program to do instead of actually writing the code? And using the flow charts. Flow charting is very useful in this way as well, because you can show loops by using arrows that show where you go backwards in the program and start over again. And that's what a loop is. So let's look at another one. Let's do some factorials. Let's do factorials. Let's do example 9.2 on page 317. So what is a factorial? A factorial is when you do 5 times 4 times 3 times 2 times 1. That's 5 factorial. Right? Whatever number of the factorial it is, you take 1 minus that number and multiply it by the original number, and then 2 minus that number minus 2. Sorry, not 1 minus that number minus 1, and then that number minus 2, and then number minus 3, and so on and so forth, until you get to 1, and you multiply them all together. So let's do that with for loop. Let's start with a number. Let's call it number equals 7. Now let's do 5. 4, 5. Number equals 5. Right? So what we want to do is we want to say 4, 1, 5. Actually, I don't even know how they're doing it. I should probably ask how they're doing it. They do a flowchart first. Okay, so anyway, for 1 to 5, I'm not really doing exactly what they're doing in the not really doing exactly what they're doing in the book, but that's okay. We're going to calculate the value of 5 factorial. Or actually, for any factorial, we're going to do this from 1 to number, any factorial. So for 1 to number, and we need to give this a value, we need to give this a variable number, so we'll call it k equals 1 to number. There we go. For k equals 1 to number, we want to do something with this k, right? So what we do is we're going to do number, we want to take our original number and we want to multiply it by itself minus 1, right? So we're going to say that we'll call this factorial equals, when we put in a new variable here, we're going to have to initialize that variable, so we have to actually start over here. Let me go ahead and just end this. So we have to have two things here. We're going to have a number. We'll let the number equal 5 this time again, too. And then we also have to have our factorial. We have to initialize factorial. Well, factorial equals 0 to initialize it. That works just fine. So then we start with 4, k equals 1 to our number. 1 to our number. Then we're going to let our factorial equal probably should have let factorial equal 1. That's okay. We'll let factorial equal number times number minus 1. But we don't want to do just this is going to be a problem because what is this going to be? What's this going to do for us? It's going to give us, the first time through, it's going to give us 5 times 5 minus 1, which is 4. Right? So it's going to give us 5 times 4. That's not what we want to do. We're not doing the same thing here, so it's not going to help me any. Okay, let's reinitialize this. Let's actually do some pseudocode really quick so we can figure this out. I'm having a hard time figuring it out in my head. So let's find a suitable thing to write on here. So let's do a little pseudocode writing. So we're starting off with a number, whatever that number is. Here's my number. And we're going to go through the loop and we want to take that number and we want to subtract it by 1. We'll subtract 1 from it. Then we want to take the number and multiply it by this number and store it. So we want to store this, put this to our computer. There's our little disk that we're going to store it to. Then we want to go back through. This thing now wants to be our new thing that we're going to subtract 1 from, right? This is going to become our new number. So this goes back up to become our new number. And then we subtract 1 from it, and then we take the one that we started with, this one now, and multiply it by the thing we subtracted 1 from. And then we keep doing that until we get down to 1, right? Until we get to we're done with this. So what we want to do is let this equal our, this can be our factorial. No, this is our factorial here. Factorial equals this. This is going to go back to become our original number, so we can call this factorial as well. But this one we want to call, this one is just factorial minus 1. We don't even have to put this in because we'll just put it in like this. So we'll start off with a number that we call factorial, which will be our number. Our factorial will start out as our number. The factorial equals this number. Then we reset our factorial to equal itself times itself minus 1. Then we put that back into factorial, into the top there, and do it again. So that's kind of what it's going to look like. So let's try to do it that way. I had it close. Okay. So for k equals 1 to 5, we have factorial is going to equal factorial. And factorial is starting as 0, so that's bad. We actually want our factorial to equal our number. So we can, but we don't want to really change our number. Well, I guess we can do it if we don't care. That number equal number times number minus 1. Where number starts as 5, but we don't want to subtract just 1, we want to subtract k. We'll subtract 1 the first time, and then 2 the second time, and then 3 the first time. We just keep replacing it as, there we go. That's how we should do it. So let's check to see if this is correct just by looking at it. For the first time we go through, we're going to start off with k equals 1, but number is going to equal 5. So we'll have 5, so number is going to equal 5, but we're going to reassign it to equal what it was originally, which is 5, times 5 minus 1, which is 4. So that's our first step, 5 times 4. And then we go back through, now number is equal to 5 times 4, which is 20. And that's where we run into the problem here, because we don't want it to equal 20 minus 20 times 20 minus 1, which is what it would be. So that's where we're running into the problem. So this does have to be equal to factorial. And let's go back here. We need to reinitialize at the very beginning. I'm just going to go ahead and end this and start again really quick. This gives us a really huge number because we're stacking it, but that's okay. So let's go back to this and let's start with our number equals 5. Initializing things can be the real challenge here for sure. Let's call this factorial equals 1. Let's start with factorial equal to 1. Is that right? It should work. Let's let factorial equal number actually. Let's let factorial equal 5 to start with. But we still need the separate number 5 in there, I think, because then we're going to use it here. So here, we go into our for loop now. For, and we're going to start with 1 all the way up to our number, for k equals 1 to our number. Oops. There we go. So in this case it would be from k equals 1 to 5. We are going to do the following. We are going to first start off with reassigning our factorial. So our factorial starts out as 5. We want it to equal factorial times our number minus k. Now let's think this through and see if it works. Does this one work? We start off with factorial equal to our number, which is 5. So it's 5 in the first time through. And then we take 5 times 5 minus 1, which is 4. And that gives us 20. Then we come back through, and factorial is equal to 20, but we need to multiply it by the number minus k. The number was 5, and k is now 2, so we multiply it by 3. And then it's 60. So 5 times 4 times 3, 5 times 4 is times 20 times 3 is 60. So now it's working. And this is what we want to do. And then we can end it. So this will calculate the factorial of 5 and then we ask what is the factorial. Oh, that's not right. Oh, it is right. What happened? Does anybody know what happened, what the mistake was? We did 5 times 4 times 3 times 2 times 1 times what?
0.
We did 0, didn't we? Because we went through the loop 5 times, and we multiplied by every number, every one of those numbers minus k, right? So on the 5th time we went through the loop, we multiplied by 5 minus 5. How do we fix that? How do we only go through this loop 4 times? Can we figure out a way to do that? What's that?
When the part 4k equals 1 to the number, you're going to take it from 1 to 0 since it starts at 1.
No, because number is 5. Number minus k is going to be 4. First time through. It's the last time through that's the problem. The last time through, you get number minus k, which is 5 at that point. Up here, we need to just change it. We need to change this to, for k equals, instead of 1 to number, we need it for k equals 1 to number minus 1, right? We need to go from k to 1 to 4, not 1 to 5. So we copy this, paste it down here. For k equals 1 to number minus 1, hit return, and then ask for it. Let's see if it worked. See if we were right. See if I was right. No, I'm still not right. Let's see. Four. Let's actually not suppress the output and see where it goes wrong. So if I undo this, it'll tell me what it does every time through. It's factorial 0 every time. So maybe you were right. Maybe that was the problem. Factorial equals factorial times. Oh, factorial is still 0 over here. Why is that? I said factorial equal to 1, didn't I? No, I said factorial equal to the number. Why is it doing that? Oh, because factorial is 0 when I finished. I gotta copy all of this stuff. So I gotta start up here. Factorial, I gotta do this. Number equals 5. Factorial, I just didn't copy everything. Okay. Number equals 5, factorial equals number, for k equals 1 to number, minus 1, factorial equals factorial times number minus k. That should work. And now let's try it. There we go. Factorial 5 is 120. So did you see what I did wrong? What I did wrong is that after the first time I ran the loop, the factorial went to 0. And then the next time I ran the loop, I didn't reset factorial. Factorial was still 0 when I went into the loop again. So I forgot to reset it. I had to go back and say that factorial needed to be equal to number outside the loop. Anything you do outside the loop only happens once. Anything you do inside the loop happens every time it goes through the loop. So if it happens outside the loop and then you run the loop again, you have to do all that stuff outside the loop again before you run the loop. So that all your variables are shut up and ready to go. But this will run the factorial of any number. If I paste all that stuff in again here, so factorial, or the number is equal to, let's make it 15. Factorial of 15 is a much bigger number, much harder to calculate in your head.
The problem, the reason it was coming up to 0 is because we didn't have the number minus 1 part.
No, the reason it was, well, that was the first reason it came up 0. when I did it again and put the number -1 in there and it came up 0 again, the reason it came up 0 again is I forgot to reset factorial equal to the number. So that always has to be in there. The factorial has to be equal to the number to start this program. So I forgot to do that. So my number now is going to be 15. My factorial is going to start out, the factorial variable is going to start out equal to that number. Then I'm going to go from k equals 1 to the number, which is 15. And now factorial, and this one actually not from 1 to the number, 1 to the number -1. We got to fix that again. Right? Then the factorial equals the factorial times the number minus k, and we end this again. And this one will be a much bigger number since factorial 15 is a much bigger number. That's what the factorial is. Huge. 1 quadrillion or something like that. 1 trillion. 1 trillion.
What if the number equals 15 quadrillion? Just the factorial equals number and down was.
Number, you have to tell what number you're taking the factorial of.
So the whole thing has.
Yep. Or you can just set the factorial equal to whatever number you want to. You could do that. But the reason I wrote in number first is because if you were putting this inside of an M file to make a function that would calculate the factorial, you would want to have a number that people entered in to your function to be to do the factorial. And it makes more sense to just call it number. But inside the program, I would prefer to call it factorial because that's where you're calculating the factorial. So it's just a more practical, I guess more user-friendly way of doing it. A better way to say that. But anyway, that is doing factorial. Let's see. Oh, they do one here. They actually do a different thing here, which is kind of interesting. They actually make a function that's going to calculate the factorial, but only calculate it when you plug in a number that is allowed to. You're allowed to calculate the factorial for it. So let's see, what are they actually doing here? Well, I did this backwards. Factorial. I was kind of. I thought the function for factorial in MATLAB was fact. It's actually factorial, so I've reassigned one of the functions in MATLAB, which means I should probably quit MATLAB and start over again so I don't have to mess with that anymore. Oh, I just reassigned one of the saved functions in MATLAB. Not a very good idea if you want things to work well. If you just restart MATLAB, it should be fine. So if I go into MATLAB when it first opens and I type in factorial of 5 like this, MATLAB actually has a function called factorial. I reassigned that function to be a variable when I opened MATLAB. And so now, after doing that, MATLAB now was looking for the variable factorial instead of the function factorial. And so it's better to use a different word for your variable, like fact instead of factorial, because MATLAB already has the built-in function factorial. If you did just what I did, you should probably reset your MATLAB. That is one of the dangers we mentioned early on in the class, is that you shouldn't use specific names for variables, right? There's certain names that MATLAB already uses that you shouldn't use. It will let you use them, but you shouldn't use them if you can avoid it, because then those particular functions are going to be rendered useless in certain situations, and also it might confuse MATLAB. It might be wanting to use the function when you wanted it to look for the value of the variable. So anyway, lesson learned. Let's do the one that they do here, which is a little bit different than the one we did. Still actually trying to figure out. Oh, they made a function. That's why I was a little confused. So let's actually make a function of this one. That's not a bad idea. Let's build a function. Let's go up here and open up a new M file and a new function file. I'm going to go up here to new, and I'm going to open up a function so that it starts it off for me here. Remember, when you're building a function, you have to start off with the word function. You have to end with end. You have output arguments here inside on this side, and you have input arguments on the other side. So in this particular function, we're not going to have, we're only going to output one thing, which is going to be the factorial. We'll just call it output. That's fine. And then we want to have the title of our function over here. Since factorial is already taken, let's just take fact. We'll use fact instead. Not fist, but fact. There we go. And then the input arguments. We want an input argument over here that makes sense. You could use x like they do in the book, or you could use number or whatever else. Let's go ahead and use x like they do in the book. That's going to be the variable that we're going to plug in. The number that we plug in is going to be x, and it's going to be assigned the value of x. Then we can go ahead and put in a summary. Fact calculates the factorial of the input by user, and will also determine if the input is a valid number for the factorial. Because not all numbers have a factorial. Negative numbers, for example, don't have a factorial. So anyway, that's our little explanation for this function, and let's go ahead and write the function. Now again, we're going to need to initialize some things and have some loops involved. We're going to start off with doing the second part of this function. We're actually going to determine whether or not a number has a factorial. So we'll use an if statement for that. Let's say if x, let's see here. Oh, we only want to do this for single numbers too. So let's see, is this? Yeah. So if this is actually, yeah, we want this to be a positive number, but we also want it to be an integer. We don't want it to be a value that has decimals in it. So to do that, what we want to do is we want to say if the length of x, if length of x is greater than 1, if length of x is greater than 1, or, remember what or is? It's the straight up and down line. Or x is less than 0. So there's two conditions. If length of x is greater than 1, or x is less than 0. Now why length of x greater than 1? In order to do decimal numbers, the array has to have more than one entry in it. It has the entry for the number before the decimal and an entry for the number after the decimal. That's how it stores those numbers. So that's how we tell if it's an integer or not. The second one is just asking if x is less than 0. If x is a negative number, then if this happens, then what we want to do is we want to tell them this number is no good. So we're going to do an output to the screen. The output, which is the output of our function, is going to equal, just just some text. Input must be a positive integer. So we just put that in quotes, it'll just print it out to the screen, and we're good to go. Now, if it is not one of these cases, then we can do an else thing. Else, this is what happens if it is positive and an integer. These things we're going to do. First thing is we have to start off by initializing a value, a variable. We'll just call it a, and we'll say a equals 1. So a equals 1 is our variable that we're going to initialize. We're not going to print it to the screen. And then we're going to create our loop for calculating our factorial. Theirs is actually a little simpler than ours was, which is nice. For k from 1 to x. So they're starting at 1 going up to the number just like we did. For k equals 1 to x, they're going to do a equals a times x. A times x. There we go. And they're not gonna print that to the screen. And then they're gonna end that right there. So that right there ends the. Let's see. That the if else statement ends right here. There should be another end in here somewhere. If else for and no, that's okay. The if else statement doesn't need an end. Apparently. Oh yeah, it does. So this end is for the for loop, and this next end is going to be for the if else loop. So then we end the if else loop. We just put an enter and put end here. But before that, we're going to output. We'll do our output equals a. So after the for loop is done, we output the a. So here we go. In ours, what did we do in our last one? I don't remember. Here. I cleared it out, so it doesn't. But anyway, that's a little bit different one, and it's quite a bit simpler than ours was, but that's fine. And we should be good. Let's go ahead and run it and see how it goes. Save that. Okay, so something in line 10 is a problem. As well as I'm expecting. Oh, we need a k equals 1 to x, not k1 to x, for k equals 1 to x. There we go. So we can run that again. Line 6, input arguments. If length, what did I do there wrong? If length, oh, this entire statement has to be in parentheses because it's an entire, this whole statement being a logic statement has to be in parentheses all at once. So let's run that. Not enough input arguments, line 6, using fact. Oh, that's right. Because I need to actually plug something into factorial. So we're going to do factorial of 5 for this one. So that's not obviously correct, because factorial of 5 should be 120. What did we do wrong here? So this loop says that a equals a times k, and then we output a. A starts as 1, so we end up with, in the first one, it would just be 1 times 1, and then 1 times 2, and then all the way up to 5. That makes sense. But we went too far. Let's take a look at our function and see what we did wrong. Mine worked better, I guess. I suppose I could have easily made a mistake here somewhere. Let's save that. Let's try it again. Nope. K equals 1 to A equals A times X for well, oh, it's not A times X, it's A times K. And then a typo and didn't see it because K and X look like each other. That's where the mistake is. Okay, so now this should work. Let's try it again. So factorial, fact of 5 should be 120. Yay, it's 120. That's much easier. That's much better. So, and this is where you start to see that you can really have programs and then programs. One program can have 2 or 3 lines, like my first for loop. Their for loop had 1 line. And that doesn't make much of a difference, 1 to 3 lines. But when it becomes 100 to 300 lines, the lines of code really start to make the program really take a long time to run. So making your programs more and more compact, more streamlined, more elegant, as they say it, is better. I am by no means an expert at this. I don't have that gift that many programmers have of seeing the simplest way that a program could calculate something, but it certainly is important. So that takes us through for loops. We move on to while loops. I'm not sure. Let's see. Trying to remember if they do anything else besides this. I think that's it. Yeah, they just do for loops and while loops in this chapter. And they nest them a little bit. So, does anybody have any questions about the for loops before we move on? Is that starting to make a little bit of sense how they're used?
Although, how does the top function
What's that?
how does the function in the notes, top part, make a difference in the command or
How does the function make a difference?
yeah. Like if you were to delete that and just type in factorial 5 at the bottom,
When you make a function, it stores it differently in MATLAB. It stores it as a little miniature program that you can then call up at any time. If you don't store it as a function, you can only use it when you're programming right then and there. So it doesn't make a whole lot of difference, except that when you're doing longer things and you really want a custom function that's going to do the same thing every time, and you won't have to change it every time you use it to fix it. With a function, it saves the function, and then if you need to change that function, you can just go and change it once and just keep using it, and the change will affect everything you do from then on out. If you don't make it a function, then you have to go back into your programming and change it every time you use it. So if you used it 50 times, you have to change it 50 times. But if you save it as a function and you need to change that function, you only have to change it once, and it changes it throughout the program every time you use it. Does that make sense?
yeah. And another thing, when we're doing the factorial and whatnot, where's that in the code on the page we're on?
That example was example number 9.2 on page 317 and went all the way to 319.
9.2?
Yeah, that factorial example we just did.
My book's talking about matrices.
Oh, which version of the book do you have? Third? You have a third edition or fourth or fifth edition?
How do you check them?
It's on the cover, right under the Holly Moore, right under the.
Doesn't say anything.
Oh goodness, is that the first edition? That might be the first edition. I don't know where it is in the first edition. It should be in the it might not even be in there as the same thing. but it would definitely be under the for loops section. If you go into the chapter on for loops, whatever chapter that is in that book. Looks like you have a much older edition than we're using. Should be in whatever chapter does loops. Did you find it?
What's the chapter called?
My chapter is called Repetition Structures. And then it's section 9.1, for loops. Yeah, unfortunately with programming books, the programs often change year to year. So each version of the book tends to change as well. Okay. All right, well, let's move on to the while loop, section 9.2. The while loop is different than a for loop in that, a for loop, you tell it how many times it's going to go through by creating a matrix that it has to follow through element by element. You say for, 7, 12, 37, negative 6, 12, or whatever. You've given it an array with 5 different numbers. It has to go through its loop 5 different times using that number for k each time it goes through. And it's a very useful thing, but it just goes through however many times you tell it to go through. So it's still not really making any real decisions. You're just telling it to do something a certain number of times with certain numbers, certain values, and then to be done. In the while loop, you can actually get the computer to make a little bit of a decision for you as it goes through the loops. So you give it conditions to look for. For example, we're going to say while the grass is green, you're going to mow the lawn every week. And that tells your kid or your lawnmower person, whatever it is, that every time they look outside and they see the lawn is green, that they have to mow the lawn. They still have to mow the lawn that week. As soon as that lawn turns brown, they don't have to mow the lawn again. But then as soon as the lawn turns green, they have to mow it again. Unfortunately, in most programs, anyway, that's neither here nor there. But anyway, it's looking for a condition to meet, or not meet. Either way, it can also look for conditions that are not met. But it's looking for conditions to decide whether or not it's going to continue the loop or not every time it goes through. So every time it starts the loop again, it looks for those conditions. If it meets those conditions, then it goes again. If it doesn't, it stops. And that's the while loop. So, and it's set up the same way, in a very similar way, except instead of using the for command, of course, we're going to use the while command, and it's going to light it up blue again, while. Of course, I need to give it some criteria. I need to give it something to ask a question. Am I going to keep going? So let's do a very simple one. We actually have to start off by initializing a variable in this case. So we'll let k equal 0 to start. And we're going to say while k is less than 3. So we're going to use some logic stuff here, right? While k is less than 3. Then I tell it what it's going to do. While k is less than 3, I'm going to let k be reassigned to be equal to what it was before. So k equals k plus 1. I'm going to add 1 to k. And while k is less than 3, it's going to do this. And I'm just going to end it there and hit enter. So the first time it goes through, it says, while k is less than 3, so it looks for what k is. Well, I set k equal to 0. So k is less than 3, so it goes and does whatever it's supposed to do. I'm going to take k, which is 0, I'm going to say k is now going to be k plus 1. So k is 0, add 1 to it, it's now 1, I reassign it to be 1. K is now 1, and I end the loop. I go back to the beginning of the loop, and I say, while k is less than 3. Well, I just reassigned k to equal 1. So k is still at less than 3, but it's now equal to 1. So I go down and I reassign k to equal what it was before, which is 1, to 1 plus 1. So now it's 2. And then I go back to the beginning and say, is k less than 3? Well, k is now 2, it's less than 3. So I go through the loop again, and I say I'm going to reassign k to equal what it is now, which is 2 plus 1. which is 3, so now k is equal to 3. Then I go back up to the loop and I say, well, k is less than 3. Well, k is now equal to 3, which is not less than 3. And the loop stops. And that's how it goes. And it prints it off every time because I told it to. And of course, you can do this with all kinds of mathematics in there. I mean, you can fill it up with different math things, all that you want. Let's see here. That's not very exciting.
So the difference between for and a while is that for it's just like a number, go through that whole process.
Yep. Until it reaches the last number you told it to use, and then it ends.
You can have like one to a number, except it's limited. You can choose whichever number.
No. Well, you can use it that way. That's the way we just used it, but that's not the only way you can use it. It can be used any number of conditions. You can have all kinds of conditions that you can set it to. So it's not necessarily going to go from one to a number. It might go all over the place and work and this condition that may be met may be all over the place. In fact, you can set up a while loop that never meets its condition and runs forever. And then it locks up MATLAB and you have to shut your computer down. Okay? So while loops can be kind of dangerous because you can have conditions that aren't impossible to meet under the situation you've done. So for example, if I said, while k is less than 3, I want k to equal k plus 0. That loop would run forever because it starts out as 0, and 0 plus 0 is 0, which is always less than 3, and it's never going to meet the condition. It's never going to say, you're never going to get k greater than 3, so it'll just keep running forever, right? Which is fine in some situations. You want that to be true for things like a nuclear power plant, right? You want the safety program on a nuclear power plant to run forever until it's not safe, right? And so if you're writing a program that's involving safety in a nuclear power plant, you say, well, this thing is safe, keep running. The one that's not safe, shut it down and turn off the power plant, right? So, it's that particular program you want to run forever, except in one particular instance where you want it to shut down. But there are many while loops that are going to be very different than this one. This one does go 1, 2, and then 3, but they might jump all over. The things might go all over the place, and you're checking it every time, and it might be, it might satisfy this condition, not this one, this one, this one. I mean, it can be crazy, crazy complicated. Okay? It's not always going to be just one number after another. This is one number after another because we added one to it every time, and that made it one number after another. It's just a very simple example. Let's go to a more complicated example. Did you have a question? No. Let's go to a more complicated example. Let's look, this one is on the bottom of page 321, and we're going to look at scores again. We're going to actually count the scores in this group of scores just like we did before, but we're going to use a while loop to do it instead. So remember, with a for loop, we first figured out how many scores there were, and then we went through the loop that many times, right? In this one, we're not going to do that. We're not going to count how many scores are in the array. So our scores equal 76, 45, 98, and 97. But those are our scores for our class. We're going to start off with a count. So 0. That's going to be the number of scores that are above 90. Right now we only got 0 of them because we haven't counted how many there are yet. And then we're going to say k equals 0. We're going to go ahead and make a little index here. And we're going to say while k is less than the length of our array. So our array is scores. Well, k is less than the length of this. So as long as k is less than the number of scores we have, we're going to first do something. We're going to increase our index number, which is k is our index number. It tells us where we are in the count. So k is going to equal to k plus 1. We're going to add 1 to k. That means we're going through it the first time when k is equal to 0. We're going through it the second time when k is equal to 1. And so on and so forth. And then we add 1 to it so that the next time we go through, we know how many times we've gone through it. Then we'll put a little if statement in here, and we'll say if scores of k. So if the first thing in scores is greater than 90, then the thing we want to do is we want to say that our count is going to equal to count plus 1. We're going to add 1 to the count of good scores and A scores, and then we're going to go ahead and end that if statement. We're going to end our while statement, and then we're going to go ahead and see what our count is. Count first becomes 1, and then it becomes 2, so there are 2 scores above this score of 90. And stop doing it once it had gone through. Once k became 4, it knew that it was at the end of that array. There are other ways to do this as well. Let's see if I can think of one here. Let's do a different thing entirely. I'm going to paste this whole thing down here and I'm going to change it. Instead of trying to count how many scores I have that are 90, I want the computer to tell me which one of the scores in this array, which is the first one to be greater than 90. So I'm not going to necessarily index anything. I'm going to index something, but I'm not going to count up numbers. So I'm going to say, while k is greater than 90, well, let's say, let's call it, oh shoot, I didn't want to hit enter there. Do this again. I don't want to count how many there are. I want to say that I'm looking for a particular score. So right now I'm going to start with a score equals 0, and I want to say, well, score is less than 90. I'm going to keep doing this, and so I'm going to keep doing this until I find a score that is greater than 90. And I'm going to add 1 to k every time, and then as soon as I get a score that's greater than 90, what I'm going to do then is I'm actually going to, if I find a score that's greater than 90, the first time I find a score that's greater than 90, I'm going to print off that score. So I'm just going to display scores at k. So this should print off the first score that's greater than 90. See if it does it. No, it didn't do it. Oh, well, score is less than 90. It does it while score is less than 90. So that's score is 0. Oh, I didn't reset my score. That's right. Okay, so let's do this again. So score, this is going to be score. I have to give a new value for score. I forgot to do that. So while score is less than the length, less than 90. So score needs a new value every time I go through. So k is going to equal k to, so here I'm going to, that's score, let's see, what did I say? K equals k plus 1. While it's less than 90, I'm going to do this. So score is going to equal scores k. So I do that if it's less than this, and then I keep going around. And then I will erase this one. This is actually going to give it to me, this is going to give me And then I'm going to do score, then I'm going to say that score k plus 1. Scores k plus 1. Now I think I've got it. There we go. That's not it either. What happened? Oh, I did do it, but I didn't suppress the output. Score equals scores k. K equals 0. It goes through once. Score equals first one, and it's should have done it. I'm not sure what it did. So in this one, what I'm doing is I'm setting score equal to 0 and k equal to 0. And the first time I go through, score is less than 90, so it will go through. It will let k equal k plus 1, so now k is equal to 1. And then we'll set score equal to the first value of scores, because it is less than 1, so that's 76. So then score is 76, which is less than 90, does it again. Then it does it again with 45. And then once 45, then it puts in 98, but 98 is not less than 90. I see what I did wrong. Okay. So I need to do this. I did the k plus 1 too many times. Copy. Paste. Okay, so I got to take the k plus 1 off of here because scores was already set. And then I need to suppress this output. I don't want to print that out every time. So then I hit return, and it'll give me the first answer in there that is greater than 90. So there it is. So this is an example where we're taking a while of something that is not necessarily changing the value by 1 every time. It's just checking the next value in the scores matrix or the scores array every time. Checking to see if it's greater than 90 or less than 90. So anyway, while statements are this conditional thing. Let's look at another example here. Different example. Oh, I don't like this one either. I want to do one that actually is a while function that is not using an incremental number. Because incremental numbers can be done with for loops. I'd rather have it look for a I don't have any very good ones here. Here's a decent one. This is another factorial one. I'm going to go ahead and clear everything out here. So remember that factorials only go until you go 5 times 4 times 3 times 2 times 1, and you're supposed to stop at that point. And so we can use a while loop to do that so that we don't go too far when we're calculating that while loop. Hold on a second, I just need to lower those. Okay, so a while loop can be used to do our factorial example again, but it is going to be slightly different than it was when we did our factorial function up here before. Let's go up here and look at this. Our factorial function before, we did this for loop in here where we went from 1 to the number, and we just successively multiplied the numbers. 1 times 2 times 1 times 2 times 3, or whatever, so on and so forth. Anyway, we just went straight up the line like that. However, a while loop can be used to do this even if they put in, even if the program wants to multiply by a 0 at some point, for example. And so let's go ahead and do this. Let's do, so do we want to do a function? Yeah, let's do a function. Let's build a new function. New function. So here's our function, and we're going to go ahead and just have an output again, just a single output we'll call output. And we'll call this fact2 instead of fact2. And our input arguments again can be just x for input. I'm not going to do an explanation again. It's the same as before, but we'll use a while loop this time, of course. And we'll have the same if statement as before, so that we exclude any numbers that are not going to have a factorial. We'll have everything the same except the for loop will be replaced with a while loop. So let's go ahead and put this in here. And let's get rid of our for loop. So let's initialize an index. K equals 1. And that's going to be a little k, not a big K. And let's go ahead and have a while. Let's say while k is less than x. Remember, the x is the number that we're going to take the factorial of, and we want to only do this while our index is less than k, so we'll increment our k. They're still doing that. I don't love it in this one, but I don't hate it as much as I do in other ones. And then we're going to go ahead and calculate our thing here. A equals A times K. So it looks very much like the for loop. We have too many ends here. We have one end for our while loop, one end for our if loop. I guess we do need one more end here for our function. So while loop ends, the if-else statement ends, and the function ends. Right there. After we end our while loop, though, we should go ahead and set our output to be equal to A. Like that. And then it'll spit out our thing here, hopefully. And we'll run it. Fact2. Let's see if it gives us the right number. It does give us the right number. So in this one, what it did is it incremented this number k, so that k was equal to 0, k was equal to 1 to start actually, then it was equal to 2, and then you multiply the a times that 2, and then times the 3, and times the 4, and it stops once k becomes the same number 5. It stops before it goes too far and multiply it and outputs the number. So that is a while loop. So we have while loops and we have for loops. Now, some things you should know. You can nest while loops inside of for loops and while loops inside of while loops. And you can have for loops inside of while loops. You can have all kinds of loops inside of other loops. And we're going to see some examples of those in just a minute. But you can also break out of a loop. You can do an if-then statement. Says right in the middle of a loop, you can say, well, if this thing happens during this calculation, then I want you to break the loop and stop the loop right there. And you use the break function to do that. And you can also do a continue function. You can say if this is true, then do this and then continue the loop again. So you can. It's kind of like taking a step out of the loop for a second and asking a question. Say, do I want to continue this loop or not? Do I want to stop this loop, or do I want to continue on? It's very useful, especially when you're using while loops that can go on forever and ever and ever. For loops are just going to go on for as long as you tell them, but while loops have to meet a condition. And if you have a while loop that's going on and on forever, sometimes you want to put in a little question that says, do I want to keep doing this loop? Is there something in here that's wrong or goofy that makes me want to break out of this loop? And so that's where we're going next, the break and continue 9.3. So here's a fairly involved while loop. Let's go ahead and do it. It's a while loop for dealing with the logarithm. We're going to start off with actually some initialization. We'll let n equals 0 to start here. And then we'll say while n, and sometimes we put these parentheses around these conditions, sometimes we don't. If you have only one condition, you usually don't have to worry about it, but if you have multiple conditions, you should put it in there so that it knows. But while n is less than 10 is just a single condition. But if you had an or an and or anything else in there, you might want to put in multiple. You might want to put in your parentheses to make sure MATLAB reads it correctly. So we're going to say while n is less than 10, and 0 is of course less than 10, so it starts off running the loop. We're going to say n is equal to n plus 1. So we're going to increment it. We're going to step it up a little, step it up 1. And then we're going to say that a is going to equal the input from this question to the user. Enter a value greater than 0. Okay? So that question's going to come up on the screen, and you're going to, whatever value they enter, you're going to put that into the variable a. And then we're going to put in an if statement here. We're going to say if a is less than or equal to 0. Oops. Less than or equal to 0. Goodness. If a is less than or equal to 0. So we're not assuming that they're putting in a number greater than 0, right? We're assuming, we're hoping that they will, but we're not assuming it. If they do put in something that's less than 0 or equal to 0, then we have to say display, we have to respond. A positive number, you dummy. Or whatever. You can be nice to them if you want. Right? And then you could say, for example, once they've done that, you could say this message will self-destruct. Right? So, and then you can break out of the program. You can break out of this program or this loop by just simply writing break, telling it to break. That if statement needs an end, so we'll end it. And we're still in our while statement because that was only part of it. We also have another thing that might happen. This first part we write is only if a was less than or equal to 0, right? We ended that, and now we're still in our while loop, and so now we need to tell it what to do if it's in the while loop. We're going to display the following text: the natural log of that number is apply and display. I'm going to display the log of a. Display that number, right? And then I'm going to end the while loop and be done. Enter a value greater than 0. I'm going to enter in negative 89. Positive number, you dummy. This message was self-destruct. It broke out of the loop, right? If I put in this long mess of stuff again, copy it and put it down here, paste, hit enter, enter a value number greater than 0, put in 8, and then I hit enter. Natural log of that number is 2.0794. Enter a value greater than 0, 1.94. So it's going to keep doing this until I put in a number that's bad. Why does it keep doing it until I put a number that's negative? What kind of loop is it? What is the condition on which this while loop will stop?
If the number is less than,
While the number is less than 10, right? As long as I plug in numbers less than 10, this thing will just keep going. I put in 4, it goes. I put in 5, it goes. I put in 2, it goes. If I put in 21, what's going to happen? I put in 21. If I put in, what did I put in? Oh, sorry. It's not N, it's A, it's not N. N will do this 10 times in a row. So what's really going on is while N is less than 10, I thought it was while A is less than 10. Well, N is less than 10. So what it does is it will do this 10 times in a row unless you put in a negative number or 0. So let's test that again. Let's see if it actually does it 10 times in a row. So here is my first one, first time, second time, third time, fourth time, fifth time, sixth time, seventh time, eighth time, 10th time. Here's my 10th time. So it does it 10 times in a row as long as you don't put in a number that is negative. So the N just counts from 1 to 10. You could put it in until A is a certain number if you wanted to. You could put it in all kinds of things, right? This is a while loop is the kind of a loop that is used for password protection. Does that make sense to you? What is the condition that a while loop breaks for? What's that? Go. You said it. What did you say? Till you get the. If the password is correct. What's another condition they might throw in there? Yeah, like 5 bad passwords, right? If you go through this 5 times without getting the right password, and it will have an increment, it will have an n plus 1 in there, right? So they might have more than one condition, right? What's that? Yeah, we're now getting into a point where we're programming real life stuff that is actually used in things that we see. And that is where programming gets cool. Because now we're starting to see how a computer can be taught to think a little bit, can be taught to use a little bit of logic to do something. We're not now just telling the computer every little step to do. We're saying, here are some conditions. In each of these conditions, this is what to do. Now I'm going to throw you to the real world and see how you do, right? That is what programming is all about. But it does take a while to get here. It does take some groundwork. We know a lot of things about programming so far just to get us to this point. We have to learn the language first of all. We have to learn how to think like a programmer. We have to learn how to organize things like a programmer. We have to learn how to do a lot of things. We have to learn a lot of the functions before we can get to this point. The functions are important because we're going to use them to tell the computer how to do things when it meets up with certain situations in the world. So now we're at that point where we can do things that are more cool. Midpoint break loops. So that break one, let's see, no. What did I just do? We just did a, yeah, now we're going to do a midpoint break loop. Okay, so in this next part, we have this thing called midpoint break loop. Let's see. Oh, that's what we just did, actually. Well, it's kind of what we just did. What we just did is actually is what is called a break and continue, and then a midpoint break loop is a similar thing, but instead of starting off with the if-else statement for the break, you do something first, and then you do an if-else statement, and then you do something again. It's written out the same way. That's what I was. So let's do a simple midpoint break loop. And this can be done with more. These breaks can be done with for loops as well. So let's look at this one. While this is funky. What does this mean? While 1. What does that mean? What does 1 mean in computer language? I'll give you a clue. What does 1 mean compared to 0 in computer language? Okay. 1 and 0 is the equivalent of all of the numbers available for the computer's language. There's ones and there's zeros. There's ons and there's off. There's yes, there's no. There's true, there's false. Okay? When you do a while parentheses 1, you're telling MATLAB to run this loop forever until it is stopped by some means. So essentially this is an infinite loop right here, unless I break the loop. Okay? So whenever you do a while 1 loop, you need to have a break in there somewhere. You need to have something that's going to break the loop eventually. So this is while 1. I'm going to say number underscore candy bars. I don't know why they make such big ones here. While num candy bars. And we want this to equal, while the number of candy bars equals an input, enter the number of candy bars. Into the number of candy bars. So in other words, what's going on here is we're gonna have this variable that we're going to create called num candy bars. It's going to equal whatever the user puts in when we ask the question into the number of candy bars. You know? And then we're going to put an if statement in here. If num candy bars, if num candy bars is less than 0, we're going to say display this, buddy. There must be a positive number of candy. Right? And once we've told it to display that, then we might do something else. If it's not a number less than 0, then we'll say the total, else total will equal num underscore candy bars times 0.75. Apparently we're going to eat something. Or maybe that's the cost. I think they're gonna ask. So this is like a register. This is a register in a store. It counts up that only adds up your cost of candy bars. Then we're gonna do f print f total cost is. We're going to pull a number out of here. It's going to be a 5. We're going to leave 5 spaces for it, and it's going to be a 2-digit number. It's going to have 2 places after the digit. So 5.2. So the 5 leaves 5 spaces for the number. The 2 is 0.2, and then we have to throw an F in there to tell us that we're pulling numbers out of there. Dollars. And then we're going to do a new line here. New line. And the thing that we're going to take that number from is the total. And then we're going to break. And it's going to keep going through this loop until it actually reaches that point. And then it will break. So no matter how many times you put bad numbers in, it will keep running until you put a good number in, then it'll calculate. Enter the total number of candy bars. I'll say -8. So there must be a positive number of candy. Enter the positivity number of candy. Enter the total number of candy bars. Well, -45. Is that a positive number? There must be a positive number. Enter the number of candy bars. Okay, I'll say 4. Undefined variable total. What happened? Total. Oh, I said total minus, not total equals. I needed total equals there. So let's copy this again. I can see another mistake I made that I'll fix really quick. Copy, paste. So this total needs to equal the number of candy bars times 75 cents, not minus. And I wrote f pront f here. I need to write f print f, not f pront f. And let's run this again. Number of candy bars, if I put in 4, then the total cost is $3 because they're 75 cents a piece. Nice. I might also put in a $sign here if I wanted to. But, you know. So that breaks and then it stops running. Once you've put in a proper number of candy bars, it's giving you the cost, and then it stops running. You could also make it stop running after you've entered 5 numbers in that way, or after by doing an incremental summary in part of it. You could also make it add up a total until you had an amount of money over a certain amount. So you got a store where people can only spend a certain amount of money, right? Or only buy a certain number of things, or something like that. Anything like that you can use as your while qualifiers or your while conditions.
I'm not coming up with the number of candy bars.
What's that?
I'm not coming up with the
So the enter the number of candy bars thing is just an input, right? Is that what you did? Num candy bars equals input. Enter the number of candy bars in single quotes in parentheses. Did you get it? Well, come take a look at your code here for a second. Let's take a look. See what it does. Well, your totals, let's say about the total is equal number of candy bars. Equal that. And the display should be equal to the value. No, it's not. Oh, you
we have to subtract.
did, but I don't. Why won't it start? Oh, you're starting to function. You're in a funky. Why is it maybe function? Go ahead and paste. No, it's not the right thing. It's not recommended. Let's see. No, I think you're in the I think you're actually in the infinite loop. I think you loop that out until you loop. That's easy. So you have to, those two arrows have to be there for it to actually do something. For it to really do something. Those two arrows up there, the prompt, then you're not actually really doing it. So go ahead and paste it in. You just got stuck in a loop, and it has to show those blue things. Then it knows your program. Go ahead and okay, fix that. Now that's a good lesson to learn though, because in MATLAB tells you it's ready to do something new by showing you the command prompt, which are these two little arrows here at the top. And if those two arrows aren't showing, then MATLAB is working. It's doing something else. And in your case, it was probably in a loop that you put it into, and you just didn't know that it hadn't stopped the loop. So it was just kept running in this infinite loop. And to stop that, you either need to break out of it. You can use Control C to break out of it, I think, or you can, or Command C or something like that. But anyway, or you can just quit, force quit MATLAB either way and start over again. So it works either way. So anyway. In the next thing to do here, we talk about nesting loops, which is on page 333, which we've already done. All it really means is that you can put loops inside of loops inside of loops, but it's really important to keep them organized. When I'm in the command window here, I'm not organizing things very well because everything's kind of all scrunched over here. If you're going to start nesting loops, I would not do it in the command window. I would either do it in an M file, a script file, or in a function. Because you can see here that it actually organizes it for you. This if-else statement has an end that is lined up with it. And the function has an end that's lined up with it. When you put this while loop nested inside of it, it offsets it by indenting it in. And then this end goes with this while. And that's a very important thing to do so that you can keep track of each loop, where it begins and where it ends. Because if you don't end a loop somewhere in there, then you're in trouble. It'll get stuck in this never-ending looping, and you may not even know what's wrong. You may not know what's wrong with your program at all. It's a very common mistake to get into. So make sure that whenever you nest loops, when you have loops inside of loops, that you're very careful. Separate them out. I would separate them vertically too. Like notice here, I put the space between this k equals 1 and a equals 1 in the while loop, and usually I put a space after the end as well. I like to make lots of space when I nest loops around each loop. So it's a very good thing to get in, habit to get into. Okay. The very last part, they talk about improving the efficiency of loops. And this comes down to a lot of different things. One of the things that you can do to improve the efficiency of a loop is just ask yourself the question, would this work better for a for loop or a while loop? For loops are generally better for things that you have to go term by term through a matrix, or you have to do it a certain number of times or it's not going to work. You can ask yourself, could I do this in a way where a while loop would work, where I'd only have to do it until I reached a certain place, until I reached a certain condition, and then I could just cut off the rest of the calculation, the rest of the nonsense. So ask yourself, which is better, for loop or a while loop? Ask yourself, is there a question I could ask in the middle of a loop to determine whether or not I can cut out early? Could I put a break in my loop somewhere and cut out early and not have to go through the rest of the iterations of the loop? You can also go within the loop and say, is there a simpler way to program this? Is there a simpler way to calculate this? And then you can test them in MATLAB. In MATLAB, you can actually time your loops. So the way to time the loops is using, well, there's a couple of different ways to do it. The first way to do it is to check the clock. So let's do an example here. So MATLAB has a clock that's running all the time. No pun intended. Let's clear this out. Let's see. Good, nice. Clear. Seals it. Okay. So everything's nice and cleared out. And let's make a what are we doing here? Oh, let's just do this. A equals 1,000. So we're creating this big array of ones. And T0, actually I need to put this in a, what I really need to do is put this in a, let's put this in a script file. Yep. So in a script file, I'm going to say ones, 1,000. So this is an array of 1,000 by 1,000 ones. So it's a pretty big deal. The next thing I'm going to do is right after I make that command, I'm going to ask what the time is on the clock, and I'm going to assign it a value. T0 is going to equal the clock. So the clock is the command you use. That's asking what time it is. Then I'm going to say that B equals A times, times pi. So I'm going to do a little calculation here. And then I'm going to ask, what was the difference between the time I started and I ended? And the way you do that is you do E time. So the E time, and you give it the starting point and the ending point. The starting point is is the thing that I assign to be, no, the ending time, then the starting time. So the ending time is clock right now. The starting time was the clock that I called T0. So ending time and starting time. And then if I go ahead and press, if I run this thing, let's see what it gives me. Oops, what did I do? Oh, I know what I did. I want this to be, I want ones to be equal to A. So A equals 1s, and then we'll run that. So it's giving me a time of 0.0034. So it took 3 thousandths of a second, 3.4 thousandths of a second to run that. The more calculations you do, the more it will take. And you can put these inside of a for loop or on outside of a for loop, either way. But you can put it on one side of a program and the other side of a program to see how long it's going to take. This little program, t0 equals clock, and then time equals e time clock t0. The other thing that you can do is you can use the tick-tock functions. We've used these, we've shown you these before, but they do the same thing. You just need to put a tick before and a tock after. So we start this one right here. We just put a tick, TIC, and then at the end we put a TOC, and it will also tell us the time. We run that. Lapse time is actually 0.0037 seconds, 700 seconds. So it turns out you get a slightly different time with these ones. The tick-tock apparently takes a little faster to run itself. It adds on a little extra time. So those are two ways that you can time your programs to see if you're getting more efficient. And time really is efficiency in computing. It's usually not memory. It used to be memory was a big deal, but memory is so cheap and easy and fast, not a big deal anymore. So time happens to be everything these days. So that is how you can use the computer to time and to improve the efficiency. So we are going to end at that point, and homework is online. Next time we are going to skip to chapter 14. To do advanced imaging stuff. So, any questions at all before we break? Good to go? Okay. Well, have a good week. We'll see you next Wednesday.